Welcome back to the Rev-based tutorials on substitution models. This next video is going to put together the different components that we did in the previous videos into the Phylogenetic CTMC, and then we're going to finally run our phylogenetic inference using Markov chain Monte Carlo. So first, we're going to define that final node from figure 1, that seq node. And this node is what we're saying our data. So when we have our nucleotide alignment data, we're saying that that data is a random variable and it's drawn from this distribution. And so we're going to do what's called in Rev-based clamp. We're going to clamp the data to this node, which is why it's grayed out in figure 1. And what this means is that this sequence data is an observation of this model. So we're going to tell it to use, for the tree, we're going to tell it to use Q, and we're going to say the DNA is the type of data. And then we're going to clamp our data and tell it that this is an observation of that model. And then we're going to wrap our model up in this using this model function so that we can use it for the MCMC function later. So you can use any of the nodes in the model to do this. It gives you Q, but you could use psi to do this, and it will make a model. And when you type my model, it'll print out all of the nodes in this graphical model. So you can see a huge list. So now we have everything with the model is set up. We need to set up our monitors now. So we're going to set up our monitors. The first of these, I'm not going to type this out. The first of these is going to output our MCMC every 10 generations. It's going to output our parameters to a log file, the value of those parameters. The next part is going to, or the next monitor is going to output our psi, our tree with branch lengths, to a different file, and that file is a trees file. And then finally, we're going to make a screen printer that's going to print to our terminal screen, and this is going to be every 100 generations. We're going to also add in here that we want to print out the TL, that monitoring parameter that we made in the previous video. So we have our monitor set up. Now we can get our MCMC going. So we need to combine with this MCMC function. We're going to create an MCMC object using our model, our monitors, and our moves. And then we can run our MCMC. So we're going to make one change here, and I'm going to run 2 runs. Okay, so you want to define this here, and yeah, okay. So when I wanted to do 2 runs because we want 2 independent replicates. You have to define that in the MCMC object. So you can see it's running 2 independent replicates, and it's doing 45 different moves, and the number of moves per iteration. We can see TLs changing here as the branch lengths are altered as moves are performed on them. So these monitored files are going to appear in an output directory in our working directory. So the next video will summarize our results and then go into our exercises.